Earth has been home to countless living beings and species for millions of years. According to current research, it is the only planet known to host life on its surface. It has witnessed multiple mass extinctions and at certain times came close to losing almost all species. Yet, one way or another, life has continued to survive on this planet, and great efforts are made to ensure its continuation. Although living beings, especially humanity, damage the planet's natural environment, scientists are working hard to reverse these damages and make Earth an even more habitable place. But sometimes, the threat that could wipe out an entire planet doesn't come from within. It comes from the vast, dark regions of space. There are unexpected dangers such as gigantic asteroids wandering aimlessly or meteors that enter Earth's orbit and fall toward our planet. For this reason, scientists conduct extensive and deep research on such scenarios that may occur in the future. Today, we will explore this belt of threats surrounding our planet and explain how scientists are working to prevent them. Before we begin, don't forget to like our videos and subscribe to our channel to support our growth. Now, if you're ready, let's take a deep journey. First, let's talk about meteors that have the potential to hit Earth. These planet-like bodies and rocky objects that could collide with our planet are generally referred to as near-Earth objects, or simply NEOs. Asteroids and comets are, of course, also included in this group. The impact of these objects varies greatly depending on their size. Objects just a few meters across do not pose much of a threat to our planet because our atmosphere acts like a shield, causing them to heat up, break apart, and disintegrate before reaching the surface. However, objects that are hundreds of meters, or sometimes even kilometers, in diameter pose a serious risk. Due to their massive size, Earth's atmosphere cannot provide enough protection to break them apart, meaning the area they impact, their surroundings, and in the case of even larger objects, the entire planet could be dragged into catastrophe. The detection of such threatening bodies is usually possible when they are still very far away. This is largely thanks to the highly successful survey programs conducted over the past 30 years. Programs such as Catalina Sky Survey, Pan-STARRS, NEOWISE, Vega/LSST have proven to be extremely useful. According to these programs, NEOs larger than 140 meters in diameter are given top priority and are classified as potentially hazardous. This prioritization makes it easier to quickly identify and monitor major threats. If scientists tried to discover every NEO, regardless of size, or if no priority system was established, small objects could consume attention and resources, while larger, more dangerous ones might go unnoticed. That's why this strategy is considered highly logical. These programs don't just detect objects, they also perform orbital calculations, characterization studies, and coordinate the assessment of potential global impacts. There are many reasons why early detection is crucial for scientists. For example, if they can identify a large object early enough, they can attempt an orbital deflection maneuver to eliminate its chances of colliding with Earth. While this may sound like something out of a science fiction movie, it is indeed possible, and has even been tested. We'll talk more about that later in this video. You may not have heard of NEOs that have fallen to Earth and caused damage to the regions they struck. In fact, there are two such events recorded in our recent history. One of them took place in 1908 and is known as the Tunguska event. This was an airburst, meaning the object did not strike the ground directly, but instead exploded in the atmosphere quite close to the surface. Estimates suggest that it exploded at an altitude of about 5 to 10 kilometers above Earth. Even though it did not directly hit the ground, it caused tremendous destruction in the surrounding area. The explosion is thought to have had the energy equivalent of 10 to 30 megatons of TNT, destroying millions of trees and heavily affecting local inhabitants. The second event was smaller in scale but still caused injuries. It occurred in 2013 and, just like Tunguska, it exploded in the atmosphere before reaching the surface. The meteoroid that caused it was only about 20 meters in diameter. However, the shockwave created by the explosion, along with the debris scattered into the area, damaged thousands of buildings and injured about 1,500 people. This meteor exploded over the Russian city of Chelyabinsk. Both of these incidents serve as proof that NEOs, no matter how small, can pose a very real danger to Earth. For this reason, scientists are working on a number of mitigation strategies. The first method is the one we already mentioned: early detection followed by intervention. You might remember that I mentioned a successful mission earlier. Scientists deliberately crashed a spacecraft into a detected asteroid. This mission was called DART, Double Asteroid Redirection Test, and the spacecraft was directed to collide with an asteroid located 11 million kilometers away from Earth. The asteroid that was targeted was Dimorphos, and scientists observed that its orbit was indeed altered after the collision. At first, this mission was seen as a huge breakthrough and a source of hope. However, later analyses revealed unexpected particle behaviors, momentum transfer issues, and many difficult-to-predict anomalies caused by the impact. So, while the project was highly successful in general, a closer look showed that it still needed improvements. That's why work on refining this method continues at full speed today. Scientists have also begun to explore other solutions. One of these involves using gravity to alter the asteroid's orbit. The idea is to send a heavy spacecraft near the object so that its gravitational pull, though extremely small, would gradually shift the asteroid's trajectory over time. This way, the asteroid would slowly drift away from a collision course with Earth. The main drawback of this method, however, is that it requires a very early detection, enough time to send the spacecraft and let gravity work its slow effect. And finally, there is the solution that many people see as more practical and short-term: using nuclear weapons. The plan here is to launch nuclear bombs toward the detected object. The explosions would shatter the asteroid into smaller fragments. Even if some of these fragments were to head toward Earth, our atmosphere would act as a shield, causing them to disintegrate before reaching the surface. This would drastically reduce the overall damage. However, the size and yield of the bomb would need to be carefully adjusted depending on the size of the incoming object. If an especially large object were detected, producing and launching a bomb powerful enough to destroy it could take too much time, meaning the response could come too late. For now, how to solve this potential scenario remains an open question. Let me share some news that might make you a little uneasy, but also excited. On April 13, 2029, a NEO called Apophis will make an extremely close approach to our planet. In fact, it will pass so close that, according to scientists' predictions, it will actually travel through the region where many of our satellites currently orbit Earth. But don't worry, analyses show that the chance of Apophis colliding with Earth is absolutely zero. What makes this event so remarkable is how rare it is for such a large object to come this close to our planet. Scientists see this as an incredible opportunity to study how NEOs react to Earth's gravity during such close encounters. Now, you might be wondering, what are the chances of a NEO big enough to wipe out an entire civilization actually colliding with Earth? Most of you might guess once every 5,000 or 10,000 years. But the truth is, the probability is far lower than you might imagine. For example, the odds of an object between 5 to 10 kilometers in diameter, large enough to cause global devastation, hitting Earth is roughly once every hundreds of millions of years. This means that such an impact might occur 100 million years from now, long after our time. Perhaps some distant descendants of ours could witness it. But don't let that comfort you too much. While the chances of civilization-ending impacts are extremely low, the probability of smaller, mid-sized asteroids hitting Earth and causing serious regional damage is much higher. Based on discovery rates, An asteroid could strike Earth once every few months, maybe once every 3 to 5 months. Space is vast, unpredictable, and it's impossible to always know exactly where and when the next object might come from. Our planet, our Earth, the only known world that harbors life, is under constant risk. Threats come not only from within, caused by humanity itself, but also from the great unknown of outer space. Humanity has the knowledge and technology to mitigate the damage we cause to our own environment and make Earth more habitable. And we are now also developing solutions to protect ourselves from dangers coming from space. So, those dramatic science fiction scenarios of giant asteroids crashing into Earth and ending the world are not very realistic. For such a thing to happen, we would have to completely fail to detect the object in advance, take no precautions, or face an object as large as a planet or our own moon, something astronomically less likely than even the rarest asteroid impact scenarios. Still, we hope that scientists will one day find solutions even for those extremely unlikely possibilities. That's all from us for today. We've talked about the threats facing our planet and the solutions being developed to defend against them. As we begin our research and preparation for the next documentary, don't forget to like this video, subscribe to our channel, and share your ideas in the comments for future episodes. Your support means everything to us, and we thank every single one of you. See you next time, and until then, stay safe.